So I solve this one and you solve this one. So take note of the difference between activity and count rate. But I'd like you to know that the general equation is the same, whether you're talking about activity or this one from decay rate or count rate. Now, C, which is the final count rate, is equal to the initial count rate, and you have this. Now, I didn't mention in our last video that you can as well write this like this, 1 over 2, and then you have n, where n is equal to t, small t, over capital T. It applies to all of them, the three of them. Is that okay? Okay, so anytime you sense that small t is given and capital T is given, this one can make your life to be much easier. Is that okay? But I think I need to prove this. Should I prove it? Let me quickly do that. Remember that decay constant is 0.693 over half-life. Do you remember? So if we plug this guy in, okay, if we substitute the value of lambda, decay constant, into this first equation, we'll have that C is equal to C naught and then times E raised to power 0.693, and then we have N, which is small t over capital T. All right. Now, this is the same thing as this negative exponent according to the law of indices. Do you remember? You have to take the inverse 1 over, and then we have what? E raised to power 0.693, like this, and then you still have here T over capital T. Okay, now if you punch your calculator, make sure you punch the shift button before punching the lane button, LN. You see a button written LN. Punch it after having punched shift. You will get that this denominator, that is E raised to power 0.693, is approximately 2. So, of course, so that you now get C naught, you have 1 all over 2, and then raised to power T, small t over capital T. I hope this is clear. Okay, so let's now answer the question. This count per minute is the initial, so C naught is 800 count per minute. C, which is the final, is what we are looking for. And then the half-life is 4, and the small t rather, is 16 days. Okay, so let's plug in the values we have. We'll have C, which is what we are looking for, is equal to 800 times, then you have 1 over 2 if we are using the formula, then raised to power n. Remember that this n here, let's solve it. T is 16 over capital T, half-life is 4, and that will give you 4. So raised to power 4 here. This is the same thing as 800 times, if you like, 0.5, then raised to power 4. If you punch this correctly, it's going to give you 50. That's 50 counts per minute. This one is the correct option. Now, if we also use the arrow method, of course, we are going to get the same thing. Okay, so let's try. You start with the C naught. All right, C naught is 800. After the first half-life, which is 4, you have 400. After the second half-life, that is 4 days, you have 200. After the third, you have 100. Then after the fourth, you have 50. Now, how do you know when to stop? This can help you. This can help you know the number of arrows. Now, much as we call it the number of half-lives, okay, you can as well suggest to you the number of arrows. Here we have 4 arrows because we got T over capital T to be equal to 4. Do you remember? So 4 arrows. Okay, so the correct answer is 50, whether you use the formula method or the arrow method. Okay, question number 11. Let's use the formula method first before using the arrow method. So the formula again is C is equal to C naught and half raised to power n, where n is small t over capital T. Okay, so let's list out the parameters. C, are we given C? Yes, this 200 is the final count rate. Remember that the question is asking us to find the count rate at 0 time, that is C naught. So what we are looking for is C naught. C is 200 count per minute. And then C naught is what we are looking for. And small t is 9 minutes. And capital T, which is half-life, is 3 minutes. So that means that n, which is T over capital T, will be equal to 9 over 3, which will give us 3. So again, remember that this n can help you know the number of arrows to draw. It also helps you to know the number of half-lives. Is that okay? Okay, so since we know that 3 is the number of half-lives, so let's go. Oh, we are using the formula method, not even the arrow method. Okay, so let's plug in the value. So we have C, which is 200, is equal to C naught. And then N is 3. Okay, so this is the same thing as 200 over C naught is equal to 1 over 2 raised to power 3. Is that okay? All right, so this is 200 over C naught. If you punch this, 0.5 raised to power 3, this should give us 0.125. All right, so that if we cross multiply, or I think I should finish it up here. Okay, so 200 over C naught is equal to 0.125. So if you cross multiply, you will get 0.125 C naught is equal to 200. Therefore, C naught is equal to 200 divided by 0.125. And this is going to give you 1,600, which should be the initial count rate. Is that okay? Okay, so that's the formula method. Let's use the arrow method. So we want to use the arrow method to still solve question number 11. Okay? All right, so I just need to know what C naught is, but C naught is what I'm looking for, and C is 200. All right, so this is where I'm going to stop. But the original one, okay, the original count rate, I don't know. So you can start with it. You can either use X or you just use it like that. So the initial count rate after the first half-life, which is 3, will be C naught over 2. All right, remember, it doesn't matter. You can start with X since it is the unknown. So after the next one, the next half-life, it will be C naught over 4. Then after the third one, it will be C naught over 8. All right. So of course, how do I know when to stop or how many arrows? You remember? You say number of arrows or number of half-lives is equal to T, small t over capital T, which in this case will be 9 over 3, which will be 3. So this can suggest to you the number of arrows or the number of half-lives. Is that okay? All right. So having got here, I know that this is equal to 200. So C naught over 8 is equal to 200. So that means that C naught is equal to 200 times 8, which will give me the same 1600. Now, some students want to apply small trick. You can even go backwards. So if I know that here is 200, so let me change this. So I know that here is 200. I can go backwards. Here will be 400. So I'll now be doing times 2 instead of divided by 2. Then here will be 800. Then here, which is the starting point, will be 1600. That's 800 times 2. So anyhow, you should get the same 1600. All right. So this one is for you. Again, pause the video and give it a try. Now, this has to do with fraction. Do you remember? Okay, so once you sense that fraction is involved, you start with 1 since the whole fraction is equal to 1. So the initial fraction will be 1. After the first half-life, okay, it will be 1 over 2. Meanwhile, I'm told that, okay, after 3 half-lives, so I know that I will have 3 arrows, okay? So after the second half-life, it will be 1 over 4. Then after the third, it will be 1 over 8. Then I'm to stop. Is that okay? Because I'm told 3 half-lives. So I stop. Now, the problem here is that the question says we should find the fraction of the radioactive material that has decayed. Here that we stop, this one is the amount remaining. Do you remember? Okay, so to now find the one that has decayed, you say the overall fraction, which is 1 minus 1 over 8. And this should give you 7 over 8, which is the correct answer. So D is the correct option.